Rafaela has contributed to advancements in cardiology so far, but I will be focusing on one specific research done by Dr. Richard Hughson on the Vascular Series Mission to space. And they performed scientific experiments on astronauts in space for 6 months. They researched how microgravity affects the heart and blood vessels because it disables the correct circulation of blood. So there are some risks and some issues involved in this that will be addressed. And I think that this is really interesting to research and to reflect on because humans are not made for space. So maybe if we have humans and organisms which are not made for space in space, maybe we can see how they adapt and even have our research be more effective on Earth and compare these two so we can create new advanced models for technology and to help medicine in the future. And maybe they will also bring us unexpected results that will bring us to new discoveries, and maybe life in space will be possible in the future. So here is the research basis. I'm going to be focusing on one dependent variable, which is a variable that changes, right? That is a variable they're investigating, and that is the arterial stiffening. In space, the arteries, they get stiffer. But however, there were other variables that were researched, such as how the glucose levels in the blood change and blood pressure changes as well. And the variable that was changing in order for the dependent variable to be researched was gravity. So we had the astronauts to perform tests on Earth and in space, and the gravity on Earth and in space, they're different. And then what the variables that were controlled in order for this research to be fair for a basis of comparison were the diet. So they maintained a strict and constant diet throughout the 6 months in space. They had the same amount of exercise, all of them, so they could be compared to how the arteries changed from Earth in space. And the level of exercise to the intensity, they also kept the same, and the review rate as well. So they had 9 astronauts split into 4 groups called the vascular echo, vascular aging, and vascular calcium. Do not ask me why they named it that way, I do not know. But that was how they named each of the groups, and they all measured levels of calcium in the blood, different variables, but I'm focusing on the vascular aging one. They measured arterial elasticity, changes in blood flow, and to do that, they performed simple exercises before and after and during their trip. They also performed blood tests before, after, and during, as well as ultrasound imaging of the femoral arteries and of the pulmonary arteries and veins as well. They compared that, and just the main arteries of the body as well. They did that mostly through ultrasound imaging, so they put the device and they just put it around their body. They also had biomonitor smart shirts, which they used, and that regulated their activity level and how much they were breathing and what their heart rate was as well. So this is David St. Jacques, and the day for the mission was a 204-day mission, and this is him taking pictures, ultrasound imaging of his blood vessels. And this research was actually performed by a Canadian astronaut, so he's a Canadian astronaut. These are some other ones. He was taking the imaging of his femoral artery, and they were all astronauts in the same mission in space. So what the results were was that they found that the arteries stiffened by 17 to 30% after 6 months in comparison to the arteries on Earth. And that means that they aged 10 to 20 years more on space than they would on Earth in average. And they also developed insulin resistance, which means that their bodies could not produce glucose normally, and that was found to be more prominent in men. And all of these have associated risks like increased heart attacks, strokes, and hypertension, and increased blood pressure too. And the insulin resistance increases the risk of developing type 2 diabetes as well. So, due to the expertise in the astronauts in fluid dynamics and how the fluids in rocket engines as well, they could develop this model, which is a heart pump, and it enables blood to be circulated correctly throughout the body while the patients are waiting for a heart transplant. So because of this research and because of what they could collect while even making the rockets and the engines themselves, they could develop this model, which was very useful for medicine, and it's widely deployed today. This is how it works, just a pump, and they can regulate it here. It's artificially regulated. So this is the man behind all of this. His name is Dr. Richard Hughson. He is the Sledgell University Chair and of the fellow Canadian Health Academy as well. He works at the Waterloo University, and these are all of what he focuses on the most of what his research focused on. He started researching because he was very interested in vascular aging and the health of the brain and the arteries. He also focuses on elders and why they get dizzy and why they have like less equilibrium when they get older. And he used to run marathons too, and then he used to test himself. So this is why he got really involved in it as well. He has, I don't remember exactly the places that he went to, but he did a PhD, an MD, and a bachelor's degree in different universities as well, but currently he is the chair in the Sledgell University of Waterloo. Thank you.